Hey guys, welcome back. This is the last video of my three-part series on how to draw your own UI objects and drag them around inside a custom subclass of an SView, namely the interactive view. If you haven't watched the first two videos, I highly recommend you to do so because this video is built on top of things we've done in the last two videos, so otherwise you might get a little bit confused as to what we're doing. So the links are posted below in the description, so please check them out if you haven't done so already. Okay, so now let's get started. At the end of the second video, we were able to construct a very basic app that looks like this. So you have a square inside an interactive view. You can drag it around. It will change color when your cursor hovers on top of it or when you press down to it. So if you drag it around, you can see that we've made sure that the square never goes beyond the bounds of the interactive view, which is great because we don't want it to. However, there are a few bugs with our current implementation, which we will be fixing in this video. One of them is that the current app doesn't handle window resizing well. So if I resize the window like this, you can see that the square has just disappeared. But if I resize back, it's still there. So a better implementation of the app would be to just push the square down so that it kind of gets stuck to the top of the window like as we resize. So it will just go down with the window and always be inside the interactive view. So this is something that we will do. Also, a bug that I realized after capturing the last video was that if you stick the square to one side of the interactive view and then you move your mouse out without entering the gray region, you realize that the cursor icon is still the hand gesture, even though it's supposed to be the arrow, like that. So this is also something that we will fix. This is an easy fix. But it could lead to bad user experience if we don't do that. And lastly, our current tracking area is fixed. So the size of the tracking area is determined by the time that this view is instantiated, which is around this size. So if we increase the size of the window to this, then this part is not covered by our current tracking area because our current tracking area is still right here, around this size. So if we drag the square here, then you'll realize that the mouse completely just doesn't work anymore. All of the mouse events aren't recognized here because this is beyond our tracking area. You can still drag it around, but you see now there's almost no gesture recognizer here. Whereas if we put the square here, then we can see that the mouse changes to a hand, and then when we exit, it changes back to an arrow, and the square changes color. So these are the three things that we will tackle. The last thing that we will do is to build a very simple user interface where the user can set the size of the square by entering into a text field or pressing on a stepper. So that will introduce some more interactive elements into our app to make it more interesting, but that will be the last thing that we do. Okay. So let's go to interactive view and make some changes to what we currently have. First, I want to organize my code because currently these few lines of code aren't in their appropriate positions. So they should really be mouse tracking related events. I might move my square up because my square is still an UI object and everything related to UI should be moved upward. Alright, so to deal with the problem of mouse exiting and the cursor not changing back, let's simply add the line mouse is in to false when we have mouse exited from the interactive view. This is because when the mouse exits from the interactive view, it is guaranteed that the mouse also exits from the square because the square is contained inside the interactive view. After we set this line, we can go to the definition and see that this will trigger a self need display request, which will redraw the UI by calling this method. We don't really need this part, so let's delete that and make our code as simple as possible. So now we have this code here. And we should have fixed the easiest problem, or the bug with our implementation. So now if I stick it to the side, well, I should really stick it to here because our tracking area doesn't cover the upper bit yet. So let me put my mouse here and then I move out. As you can see, now the cursor updates according to the position, whereas in the past it's still a hand icon right here. Okay, so we have fixed one problem. Good. Now let's work on the other ones. So let's tackle the problem of the tracking area not changing with the size of the window next. So before we do anything, let's try to make our code more reusable by copying this part of the code into its own private function. Let's call it update tracking area. And before we add our new tracking area, we want to get rid of the old tracking areas because they are no good for us because they were responsible for other window sizes. So what we can do is iterate through the existing tracking area. So for existing tracking area in self.tracking areas, self.remove tracking area, existing tracking area. So this loop will remove all of the existing tracking area, and after that let's add a new tracking area like that. So this function will make sure that our user interface is always using newest tracking area size. And let's write update tracking area here. Something else we need to do is to actually fetch the size of the window, because when the user resizes the window, the interactive view itself doesn't really know what's going on. It doesn't even know the user has resized. So we want some kind of function that that will be called when the user changes the size of the window. Something like window has resized. And after this happens, we want to update the tracking area. This is something that we want. But how do we call window has resized when the user actually resizes the window? So in order to do that, we need to communicate with view controller, which can communicate with window controller. It is rather difficult for the interactive controller to directly communicate with the window controller because they are just in different levels. And usually the convention is that you go through the view controller. So let's reference the interactive view by giving it a name. IB outlet weak var interactive view, and then the class will be in this interactive view. Oh, wait, not in this, just interactive view. Yeah. So now we have referenced interactive view, but we need to connect it to the actual interface. So we drag it like that. Interactive view. For those of you who don't know what I just did, I just pressed down Control and dragged. So if you press Control, you see that arrow. All right. So now we have referenced interactive view from view controller. But the view controller doesn't really know anything about how the window is behaving. So why don't we go here and add in this window delegate and set the Windows delegate to self. So this means that this class is responsible for all of the events related to Windows, in particular this window. So when the window has resized, we want to call this delegate method. So this will say, so this will make sure that our interactive view is going to update according to the size of the window. So let's first refer to our view controller here. The way we do it is let's set view controller to self.content view controller. So this will refer to the view controller of the or just the content view controller. It's pretty self-explanatory, and we cast that to a view controller. And the reason we need to do it is because we want to refer to this particular view controller. we can't just refer to it as a generic index view controller, because a generic view controller doesn't contain an interactive view. And we know that this cast will always be successful because the content view controller is of the class view controller. So after we've referred to this view controller, we can access the interactive view. .interactive view window has resized. So after writing this code, the interactive view is able to respond to window resize events, even though it's not the direct delegate of the window. So now let's add some more stuff to this function, because we don't only need to update the tracking area. We also want to make sure that the square gets pushed downwards and always remain inside the interactive view. So in order to do that, we need to set some constraints on the position of the MySquare object. Notice that the origin of the MySquare object starts from the bottom left corner. And that means the maximum origin position of MySquare has X component that is never exceed has an X component that never exceeds the width of interactive view minus the width of the square. And then for the Y component, this will never exceed the height of the interactive view minus the height of the square. So this will set some constraints on the X and Y component, which is the origin of the square. And once we do that, we can always make sure that the square stays inside the interactive view, no matter how the window gets resized. So let's define, or we don't really need to define anything. We can just set MySquare.origin.x. Let's set it to the minimum of the current origin.x and frame.width minus MySquare.width. So this is the maximum possible x value for the origin of the square. So we take the minimum and we make sure that it is never going to exceed this value. Similarly, let's write MySquare.origin.y equals the minimum of MySquare.origin.y and then frame.height minus MySquare.height. So after this method is run, the square will automatically adjust its current location so that it will remain inside the window. Let's save it and run and see what happens. Cool. So now let's drag it here. First, we can see that now the tracking area covers this huge window, even though by default it only covers this size. So that's something something that we have improved. Also, when we stick the square to the top and we resize the window like this, notice how the square is also getting pushed down instead of just remaining here and become invisible to the user. So I consider this as an improvement to the user experience. Well, even though this isn't really an app that anyone would use, it's just a demo. But the idea is that you want to get rid of all possible things that will cause bad user experience. And this is something that improves user experience by having the square not sticking out and then becoming invisible when the user resizes. So we're almost done. There's one more thing that we want to do, and that is we want to add a small user interface for the user to customize the size of the square. And the reason I chose to include this in the tutorial is so that you can see how different UI elements can interact with each other, and also to make this this app more interesting by allowing the user to change the size of the square. So let's quit this and go to the main.storyboard. Before we add anything new to it, let's first disable the bottom constraint of the interactive view. That's because we want to add some stuff to it so the interactive view can no longer be a distance of 20 from the bottom. Instead, it needs to be something like 50 away from the bottom. But let's just decide what value this should be after we insert the new items. So just delete it. And let's drag it down a little bit to give it some room. And then press Shift Command L to bring up the NS object search interface. And let's choose a text field. And just place it here. Let's also choose a stepper, so that the user doesn't have to always enter a number. Instead, they can just press this stepper value. These two values should be in sync with one another. So if you change the number here and then you press stepper, the stepper should update the new value instead of updating the existing value inside the stepper. I'll explain how this works later. But let's change the position of these two so that they look nice. Let's align this to the center. Let's give it a placeholder string of square size, something like that. Let's set the default size to 50. Let's align this to the right side. For the stepper, we also want to customize it. We want the minimum to be, say, 50, because we don't want the square to be too small. We can set the maximum to be 300, because there's no need why the user wants to make the square too big. The current value is 50. That's good because that's the default size. We want to increment the size of the square by 10 pixels each time instead of 1 pixel each time. This will make it a little bit better. Alright, so now we need to set some constraints so that these things will automatically change their position based on the layout of the window. So let's set this one center horizontally. Let's set the bottom space to be fixed, bottom space. This one horizontal spacing, and then the bottom spacing as well, bottom space. And then let's set the width of the text field to be fixed, like that. And then let's set it to something like -5 so that these two objects together will be the center of the X component. So let's set it to something like -5. Okay. Yeah, this looks good. This is all set. So now let's connect interactive view to the things at the bottom. Let's set the size to 50. And then let's connect it to this one and keep the vertical spacing fixed. So now everything resizes nicely with the window, even though these two things don't do anything yet. So let's write some code to make these two useful. So back in view controller, let's delete this. Default method is not useful here. Let's add two references. Let's add IV outlet leave var text field to refer to our text field in this text field. Let's also add an IB outlet leave var stepper, and that will be of class NS stepper. And we want a function that updates the value of the stepper when the user enters something into the text field, and vice versa. So let's do user updated text field. I like to name my functions very clearly, even though these might be long, so that I always understand what's happening. So let's say the user has updated the text field. Then the sender will be an NS text field. In this case, the sender will always be this particular text field because that's the only one we have in the user interface. So then we do something, right? We're supposed to update the stepper, and then we also want to update the square from the interactive view. And let's write another function that updates the value of the text field when the user changes stepper. So let's do user updated stepper. The sender will be the stepper, which is guaranteed to be this stepper because that's the only stepper we have inside our app. So let's get started with this function first because it's a little bit easier. And the reason is because the stepper has its own intrinsic minimum value and maximum value. So we can make sure that the value from the stepper is always a valid number. So we can set text field dot double value equals to sender dot double value. And sender represents the stepper in this case. And we also want to update the interactive view. Right, so now here we want to update the stepper. So let's set stepper dot double value equals to text field dot double value. Okay. Now we also want to update the size of the square. And in order to do that, we should write a method here that changes the size of the square. So let's write something like func update square size, and then it will take in a size as a double, and then it will update my square dot size dot width to CG float of size. The reason I'm using a CG float here is because the value of this is CG float, so I need to wrap this around to cast it to CG float. My square dot size dot height is equals to the same thing, CG float of size. After that, we want to call window has resized. Although window hasn't actually been resized, we know that this function is able to take care of the display of the square to make sure it's always inside the window. So let's just call it so that we know that the square is contained inside the window after the resize. Okay, so once we have this method from interactive view, we can call it from our view controller. So let's write interactive view dot update square size, and the size will be the steppers dot double value. The reason we want to do it using the stepper instead of the text field is because the text field's double value could be something bad like 0, but the stepper has its own min size and max size, so this will always be some good value. Okay, so that's why we're using that. Oh, and by the way, we should also update text field dot double value to stepper dot double value, so that if the user enters something bad, they will see that it hasn't been applied to the square. Okay, so now we've finished this function. Let's add a line that changes the size of the square here. So interactive view dot update square size, and change that to sender dot double value. Okay, so now let's actually link these two functions to the text field and the stepper. To do that, we need to give it a tag of IB action, so that this means that this is some function for a particular init object. IB action. Let's do that too. Now let's save that. Go to main.storyboard and link these two. Right click, and then here we have user updated stepper, user updated text field. So for stepper, let's drag it to the stepper. For updated text field, let's drag from the text field. For the text field, I think we should set it so that the action is sent on enter only, so that the action will be triggered only if the user presses the return key. So I think we are all set. Let me just check again to see that we have all the functions. Okay. Oh, these two aren't connected. I thought I've connected them. Oh, yeah, okay. So the stepper should be connected to the stepper. The text field should be connected to the text field. Right. And let's save the user interface. Okay, now these are connected. The interactive view is able to respond to the update square size method. Okay, let's run and see what happens. Alright, so now we have the square. The default size is still 50. Let's update it to something like 100. See how it looks like, or like 200. Okay, now the square gets really big, but it is still within contained within this window, which is nice. And then we can also drag it, just like how we can drag the 50 pixel by 50 pixel square. Let's see that we can't make it anything smaller than 50 because that's the minimum size of the stepper. There is a small problem that we should have avoided, and that is the size of the stepper can never exceed a certain value, and that value is determined by the size of the window. So what I mean by that is if you wait, hold on. Okay, so if the window size is like this, it's like this, then you shouldn't be able to make the stepper any bigger because this is simply bigger than the size of the window, right? And you see now this is not behaving the way that it's supposed to be. It's like kind of squished. Okay, so let's just do that, and that will be the last thing that we'll do in this tutorial. So back in the view controller, when it handles it doesn't really handle any window resize event. So let's create a new function called respond to window resize, and let's do something like stepper dot max value. Let's change this max value to the max value that the square can be. But we haven't really defined how big the square can be. So let's go back here and define a new function, max square size, which returns a double. Here, let's just return the minimum of frame.width minus my square.width. Sorry, my square.origin.x. And then frame.height minus my square.origin.y. So this is the biggest size that the square can grow, right? Wait, actually, since the square is able to go downwards, let's change this. Let's change this to the minimum of this frame.width and frame.height. Okay. So in view controller, let's set the stepper's max value to interactive view.max square size. So this will make sure that the square can't just grow too big, because then it will just not fit into the window. Ooh. Oh, we need to convert this to a double. Okay. Okay, so now let's test the new function by giving the window a very long but thin space. So let's try to increase the size of the square. Ooh, still able to increase. Oh, okay, I see what's happening. When the window gets resized, we really want to call vc.respond to window resize as well, because currently the view controller doesn't respond to window resize events. So let's do the same thing. Let's give it a very long but thin space and then try to increase it. Yeah, so now you can't increase the size of the square anymore because then it just won't fit into the window. Similarly, if I have a space that looks like this, and I try to grow the size of the square, then I encounter maximum size. And then there's nothing I could do beyond this, which is pretty cool, I think. So that's it for this tutorial. I hope that you have enjoyed making your own interactive view and be able to drag an UI object that you have created using the Cocoa Framework's draw function inside here. Please post any questions you have in the comments. If I have not explained anything clearly, I apologize. Please just ask them. I'll try to respond. Okay. I'll also post the source code for this entire project onto a GitHub repo, and then I'll post the link in the description. So see you next time.